Hey guys, so today I'm going to take a look at the review for the final exam. In this video, I will go over questions 1, 2, 5, 6, and 9. You can find the other 4 problems in another video that is linked and posted in my courses. All right, so let's start right off the bat with number 1. I'm not going to write out the problem. I will just go through the solutions here. So problem number 1, it's talking about consumers and if they have a preference for the type of cola or Pepsi versus Coke. And the Pepsi company would like to convince others that more than 50% of consumers prefer Pepsi. So they took a random sample of 100 consumers and did a taste test. And they found that 56 out of that 100 chose Pepsi. So now it says, does the sample provide sufficient evidence to support the idea that more than half of the consumers prefer Pepsi? That's my goal right there. So it says complete hypothesis test with a process learned in class using a 5% level of significance. So for this one, it's clearly a hypothesis test because it states that, right? And it tells me my level of significance. So I'm going to start right away with my population step. So for my population step, I need to identify the objects. And I need to identify the variable, the unknown, and the goal. Okay. Let me get this focused. I feel like it's not focused properly. I don't know if that's better. Okay. All right. So here, for my objects for this problem, the objects, you can write it a couple different ways. You can write people, you can write consumers, whatever you want to do. So I'm just going to go ahead and say consumers. That's the wording in the problem. Then my variable is, what are we studying about the consumers? So we want to know, do they prefer Pepsi over Coke? So I'm just going to write prefer Pepsi. And you can write it as a question, like with a question mark. You can write this several different ways. Yes, no. When I write the yes, no there, that indicates to me that this is categorical. So there's a lot of things pointing to categorical. It's talking about a percentage right there off the bat, it's categorical. It doesn't say anything about means or standard deviations. So I know it's not numerical and it's not a meaningful number. We want to know out of a total of how many, out of a total group of people, how many prefer. So it's a percentage. Okay. So therefore, if my variable is categorical, my unknown is P, and P represents the population proportion. Now, that's what P always is. It's just, I want to add some context to this. So P is the population proportion of consumers who prefer Pepsi. And there it is. Okay. So in my unknown, I want to make sure I identify my unknown. So P for categorical, mu for numerical. And I want to define that value. Now my goal, I'm going to come back to that in a minute because my goal is always to show support for HA. I just need to figure out what my HA is. I'm going to leave some space and jump down to my method step where I will write out my HA in notation form, and then I can write it out in words and my goal. So in my method, I want my null, my alternative. I'm going to identify alpha and what curve I'm on. So I'll start with the curve. It's a categorical problem. So the curve that I'm studying is the Z curve. So this tells me what curve I'm using in my calculations down in my results step. Alpha was given to me. It's my level of significance. It's 5%, but I'm going to write it as a decimal because we use it in decimal form later on in my conclusion. Now, my HA, remember the HA is always what matches the wording in the problem, what someone's trying to convince, what they're trying to do, what they want to show, whatever that is, that's my HA. So it says that the cola company would like to convince others that more than 50% of consumers prefer Pepsi. So it's my unknown here, P, and it's more than. So P is greater than 50%. So I'm going to write 50% as a decimal, 0.50. That's how we will use it in our calculations. Okay. Now my null, I can write it two different ways. I'm going to write it as P is equal to 0.50, or you could always write it as P is whatever the opposite of this is. So less than or equal to 0.50. Either way works. So I know in algebra, these two are not equivalent, but when we're looking at hypothesis tests here in stats, these two mean the same thing right now. So it doesn't matter which way you write it, either is fine with me. Okay, so now I have my HA that P is greater than 0.5. Well, I've already written out P above. P is the population proportion of consumers who prefer Pepsi. So now I'm just going to rewrite that down here in my goal and then tack on the end the greater than 50% or greater than 0.5, whichever one you choose to write. So I'm just going to write that my goal is to say that the population proportion of consumers who prefer Pepsi is more than 50%. There we are. So now there's my goal. All right. So I'm going to move on to the next step, which is my sample step. This is the quick, simple step, because all I'm doing is I'm just taking the information that's given to me in the problem and I'm going to just organize it and have it written nice. Now, you know what I include in my sample step depends on the type of data I have, right? So since we have the categorical, I'm going to need to identify X, N, P hat, and check for normality. Now, when I check for normality here, my normality check for categorical is N times P naught times 1 minus P naught is greater than or equal to 10. Okay. All right, so X, the number of people in the study who answered yes if they prefer Pepsi, that was 56. N is the total people in the sample, that's 100. P hat is just X over N, so it's 56 over 100 equals 0.56. Now, sometimes people ask me, do they have to show all of this work? No, you could just write P hat's 0.56. That's fine with me, okay? Now, for the normality check, you do have to show your work. So I want to see what values you're plugging in. And the reason is because people will want to plug in P hat, but it's not P hat, it's P naught. P naught, remember, is the value from your null, which is 0.5. So it's 100 times 0.5 times 1 minus 0.5. And I want to know, is that greater than or equal to 10? Well, yes, it is, because it's 25. So I have 25 is greater than or equal to 10. So to just say, yes, it's normal. That's what I look for in that step. That's kind of a nice quick step. You don't have to really think a lot other than what value we're plugging in for my normality check. It's just pulling the information out of the problem. Okay, so now the next two steps are really where we're getting into figuring out what's going on with the problem, right? The first three are just gathering information about the problem. So the next step is my results. So my results step, I want to find my test statistic, and since it's categorical, it's Z, right? That's why we stated it's the Z curve. I need to find that value. I need to interpret that value. I need to find my P value, and I need to interpret that value. So I'm going to use my calculator for this one. So for my calculator, I'm going to use the testing function. Remember, you don't have to do it this way. You can find each one individually by using the formula and by using your normal CDF, but I'm going to use the calculator function. I can find that under stat test. Now it's categorical. It's not this first one. A lot of people want to choose number 1. It's not number 1. You need to go down to number 5, one proportion z-test. Okay, so get in here. So my P naught here, remember that's from my null, that's 0.50. X is 56, N is 100. Now this next line, I need to match the inequality here to my HA. My HA is greater than, so I need to arrow all the way over to the right and select that one and then calculate. So what I like about this, it just gives me all my calculations all at once and I don't have to do anything else by hand. And I don't really need to do a drawing in that case. So it says my z-test statistic is 1.2, right? And then it says that my p-value is 0.115. So if you wanted to do this, maybe you should show a little work saying like 1 proportion z-test and just tell me what you're plugging in. Like that you're plugging in 0.5 for your p naught. I don't know. I mean, you can just write 0.5. You could write p naught equals 0.5. Then I know x. So it's basically what you just had in your sample and then the greater than, maybe something like that. Gives me a little information about what you plugged in. That way, if something's not right here, I can maybe look at this and give you some partial credit, that kind of thing. Okay, that's all that would be for. Okay, so my z-test statistic 1.2. So what this stands for is it's saying that my p hat, so my sample proportion, is 1.2 standard errors. It's above, because it's positive, the center of 0.50. So I'm going to draw a picture anyways, even though I said we don't have to, because I think the visual is really helpful. So now if I'm on my z curve, this is z, my center is 0, I'm at 1.2. So right here, I'm at 1.2. So what we need to do is we need to find the area in the tail over here, which we already did, and that's the 0.115. So what we're going to do is in the conclusion step, we're going to compare this to alpha. Well, alpha is 5%. So if this was 11.5%, 5% somewhere is over here in the red would be 0.05. Okay, so my sample is closer to the center than my 5% mark. So that means it's not less than, right? All right, so let's interpret the p-value, then we'll get to that with our conclusion. So the p-value, I always want to state what the center is because that's how we based this calculation, right? On the center being the 0.5. So I'm just going to say if the population proportion is 0.5, there is a 0.115 probability of getting a sample proportion, so another p hat, at least as extreme as the one we got from sampling. So what that's saying is that I have an 11.5% chance of getting another sample proportion, so another p hat this far away from the center or further away. Okay, that's what that's saying. Remember, the whole concept behind hypothesis testing is that if my sample's that far away, further away than the 5% mark or my alpha, my level of significance, then maybe the center should not be the center. All right. Let's move on to my last step, my conclusion step. So here I'm going to ask myself, is 0.115 less than or equal to 0.05? So I'm always asking myself the same question. This inequality never changes. So is my p-value less than or equal to my alpha? It's not, right? I'm going to look at it in percentages. If I have a hard time with decimals, it's 11.5. Is that less than 5%? No. So I'm just going to say we cannot reject our null. So now I'm going to make my conclusion statement. So at the 5%, level of significance. We cannot say, now I'll rewrite my goal, that the population proportion of consumers who prefer Pepsi is more than 50%. There it is. So we're saying that that is not a true statement, that it's not more. So the center should stay where it is. We don't think the center should be moved over to the right where it's greater than. Right? That's what we're saying. Okay, so that was problem number 1. Let's move on to problem number 2. Okay, so problem number 2. Okay, so this one, we're looking at probability. I know right off the bat I'm looking at probability before I even read it because I can see the two-way table. So looking at a region that someone lives in, northeast, southeast, west, and if they like their opinion of a clam chowder, okay, if they like it or not. So like, dislike, or uncertain, they're on the fence. Okay, so here in part A, it says, what is the probability that a person is in the study is from the northeast and likes? So my notation is probability from northeast. Maybe I should change that. I'll just write out and, I guess, and likes. This looks like my and symbol. Okay, so northeast and likes. Now I am going to pull up the, I didn't write it out anywhere else, so I'm just going to pull this up here, my solution. So when I'm, maybe I'll just rewrite this because I want to be able to do this. Okay, I'm just going to fill out my chart real quick here. So then we can kind of see what's going on. Sorry, I didn't do this ahead of time. And it's crooked. We'll get the idea. So if we use the chart and the shading, there. Let's put some totals in here. Not that we need them, but. Okay. All right, so if we're looking at A, so the probability that they're from the northeast, so that's up here, and they like here. So remember, that's the overlap. So instead of shading, I'm just going to kind of use my pens. So I'm going to look at the overlap, so it's where they cross, the intersection. So my numerator here is 30, and my denominator is my table total of 240. Remember, you don't need to reduce your fractions for me. I actually prefer that you don't, then everyone just has them in the same format. Okay. Now, if you want to use this with a formula, you're going to multiply the probability of n times the probability of L given n has already occurred. So the probability of n, so that's the northeast, it's 60 out of the 240. And the probability of L given n. So remember, L given n is I have this restriction that n has already taken place, and I'm just looking at the L, so it's the 30 out of 60. The 60s cancel, and I'm left with 30 out of 240. Same answer, right? So it doesn't matter which way you use. You solve, if you use the table or if you just use the formulas. Okay, so what is the probability that a person in the study likes? Okay, so just the probability of L. Okay, so just the probability of L, so likes, so we're looking at 80 out of 240. Part C, what's the probability the person in the study is from the northeast or likes? So it's the probability that they're from the northeast or likes. Now remember, this is not the intersection, it's where I'm looking at both together. So we're going to kind of look at the same thing. So likes and from the Northeast. So I'm going to add all of those boxes. I'm going to add this entire column, not including the total, of course, and this entire row, not including the total. But I only add this box once. I don't want to double count those 30 people, right? If I've already counted them in the likes, then I don't want to count them here in the Northeast. I hope that makes sense. So when you do the shading, you would shade that column in that row, and you would just count every box once, and then that makes it so you only count those 30 people one time and you don't double count. So here I have 80, so I'm going to look at this. I have 80 for the likes, and I know I have 60. So you can, I'm going to just look at it like the shading. So plus 15 plus 15. Okay, if I was doing the shading, and this is all out of the total for the table, which is 240. Okay. So I have 110 out of 240. Now, if we were going to look at this with the rules for probability and the formulas, then I'm looking at the probability of N plus the probability of L minus the probability of N and L. That's the overlap. So the probability of N is 60 over 240 plus L, which is 80 over 240, minus the combination of the two, which is 30 over 240, which gives me the same answer, 110 over 2. Okay. All right, part D. The person studies from the West, what's the probability that they like? So this is a given, this is a conditional probability. So the probability, it's always the one you list first is always what you're looking for. So what is the probability that they like? So the probability that they like, given they're from the West. Now remember, this is the one in the table where you look at the shading in the restriction, where you outline the restriction. So the restriction is the second one, the West. So I'm only looking in this row. Okay, so that's my denominator, that 120. So out of the 120, out of just the West, what's the probability that they like? It's 40. You see that? So I would just shade that one in and just outline this whole thing. So out of the 120, 40. Now, if you were doing this with formulas, then I'm looking at the probability of likes and from the West divided by just the probability of the West. That's my formula. So remember what the and represents, the overlap, right? So likes and West, where they overlap here. So that's 40 out of the 240, my table total, divided by just the probability of W, which is 120 out of 240. My denominators cancel. So it's 40 out of 120. There it is. Okay. Now part E, I'm glad this one's on here because this is like an exam question that a lot of us missed. I want to know which events are mutually exclusive or disjoint. That means no overlap. Okay, so I'm looking for no overlap. That means that either two events have a probability of 0, or it means you're looking at two columns or any two rows, right? So any two regions, like someone can't live in both regions, right? Or they can't have both two opinions. That's all that means. So if you're looking at this, the answer is A, because I have uncertain and dislike, which are two opinions, and we can't have both. So it's no overlap. All right, so that was question 2. Let's take a look at question number 5. So remember, questions 3 and 4 and 7 and 8 are on another video, a separate video for you to look at. So I'm going to look at question number 5. Question number 5 here. Okay, looking right off the bat at this problem, I'm just going to show it real quick. Looking at this, I have an X and a Y. Right away, I know this is regression, chapter 4. And then look at, I have my scatter plot here. So when I'm looking at this problem, I'm starting to think about X and Y and regression and what I need to do. The first thing I need to do is I need to take this data that's given to me and I need to plug them into 2 different lists in my calculator. So it doesn't matter which list you plug into, like if this was list 1 and list 2, but maybe like write it down, like list 1, list 2, so you don't mix them up. Okay, that would be my suggestion. Okay, so I'm going to plug all of my information into my calculator, which I don't have, so I have to do that quickly myself. So to do that, just as a refresher, because this was a while ago, stat and then edit. So enter here. I have all these lists. So I'm going to go to list 6 for my X, and I'm just going to enter in all these values real quick. I say real quick, but I'm not that quick at it. So I don't want to make a mistake. So go ahead and do the same thing if you haven't done so already. And then I'm going to, of course, I don't have any more than 6 lists. So I'm going to use list 5 for my Y. This is why you write it down. If you need to clear all the data in a list, just go to clear when you're on the list and then enter. It doesn't delete it. If you delete, you will delete the whole list. The column will be gone until you reset your calculator. Here, I just cleared. Okay. So now I'm going to type in these values. Hopefully I don't make a mistake. I normally go back through and double check. Then that way I don't have to worry because it's so easy to make a mistake. Okay, so I'm just going to go back and just double check, and hopefully I'm just trying to be quick. But this actually is good practice for you guys too, to double check your numbers, especially on an exam. Okay. Remember, they have to match up, right? Like you don't want to disrupt the order because then you're messing with the data because they're paired. Okay. All right. So I have my lists in there. So I'm going to go ahead and not clear, but quit. So second mode. Quits gets me out of there. Okay, so now to run my regression stat, calc, and option number 4. So it's chapter number 4, option number 4, AX plus B. All right, so I need to tell my X was list 5, so I'm actually going to leave that alone. And then my Y is list 6, so I'm going to enter that in here and then go down to calculate. All right, so now if you're at this point and you only get A and B, you don't get R and R squared, remember you have to turn your diagnostics on. You go to second 0, that's your catalog, arrow all the way down to diagnostics on, hit enter twice, and then go back in to your regression and you'll be able to get that. All right, so here for part A, it says compute the correlation value. The correlation value is just R. So it's R is equal to 0.8641. I normally ask for 2 decimal places, but I'm just going to put 4 right here. It says, what is the value for the correlation indicate about the strength and the direction of the linear relationship between length and age? I really gave you a lot of information on this one. Like you don't even have to put a lot of thought into this because I gave you the statement, the sentence. So here I'm just going to say there is a strong, now remember, the closer to 1 or -1, the stronger the relationship. So a strong positive linear, those are the 3 words. These are key here. Strong positive linear relationship between age and length. There it is. So when I'm grading something like this, I look for strong positive linear, age, and length. I will look for the context of that problem. Okay. That's my interpretation of this number. It's what it means to me for this problem. Okay, part B, what is the equation of the regression line? That's my Y equals AX plus B. I'm just going to take it right from my calculator. Sorry, it's hard to see right there. So remember, I write it as Y hat because Y hat indicates it's predicted, where Y is my actual. So here I have, just make sure. let's see. I don't know if I got it actually that's interesting. I don't know if I got the right. I don't have it right. Hang on. Let me see. I think I plugged in the wrong. I got to check this. I think I plugged in the wrong. I think X was 6. Sorry, guys. And Y was 5. If you're watching the video, you're probably saying, wait, you're plugging the wrong one. There, that's better. I definitely I mixed my X and Y up because I did not write it down. There you go. There it is. Okay, so my R value is still the same. Okay, it's still showing the same relationship here. So I'm glad I just caught that. So Y hat is equal to 25.6199 times X. Now, I like to leave quite a few decimals here, not round too much, because if I'm going to use this equation later on, I don't know if I am in this problem or not, but if I do, then I'm getting a more accurate answer later on. Okay. And my y-intercept is plus 891.89, or let's see, 8892. There we go, to be consistent with 4. So there's my equation of my regression line. Now for part C, write a sentence to interpret the slope. So remember, the slope is right here. It's the 25, and that represents, for each unit increase in X, my Y will increase, because this is positive, by that 25 number. Okay, so I'm going to say, for every day increase in age, the length of the fish, because I want to be complete context here, will increase because it's positive by 25.6199. You could round on this point, okay? You could round to 25.62 or something if you wanted, or 25.6, that would be fine with me. Okay, so that's my interpretation. For each unit increase in X, my Y will increase by this number. If it was a negative number, it would be decrease. All right, so for this data, what is R squared? R squared was given to me in my calculator. It's just the 0.8641 actually being squared. So I get 0.7467. This one, I always include 4 decimal places because I want to write it as a percentage. Oops. I'm looking and reading 7, but I wrote 5. Okay, there we go. So 74.67%. So now it says, okay, write a sentence to interpret this. So this is the amount of spread that's in my Y, okay? So in the length that's being explained by the equation of my line. So I'm just going to say 74.67% of the spread, or you could say variation, of course, in context, in fish length, jumping ahead of myself here, can be explained by the regression line. You can write that. If you wanted to include the equation, you can include the equation. Write a couple different things. All right, E, what length would you predict for a fish who is 50 days old? So this is where I'm just going to take 50 and plug it into X. So Y hat is equal to 25.6199 times 50 plus 891.8892. Okay, so my Y hat, my predicted value is 2172.88 UM. There it is. This is my predicted value. Okay. All right, so that's number 5. Okay, let's take a look at number 6. Okay, number 6 is a box plot. So number 6 here, okay, this is kind of a morbid problem, infant mortality, that's sad. Anyways, so it has countries listed and the mortality rate. It says right here, draw a box plot. That's how I knew it was a box plot right away in the directions. Says draw a box plot. Okay, so let's just go right through these. So the first thing I need to do is I need to take my data here and plug it all into my calculator. So stat edit for your list. Okay, and then plug all those values into your calculator. Once you're to that point, you will go to stat calculate in the very first option, one variable stats. So if you go into one variable stats, I don't have it plugged in here right now, but if you go into one variable stats and calculate, it gives you all of like your X bar, your S, your standard deviation stuff, and then you arrow down. Excuse me, this is where you find your 5-number summary. Okay, so just so you know where to find it. So when you plug this in, you're going to get your 5-number summary. So it says draw a box plot showing any outliers for the mortality rates. Be sure to label it properly. Okay, so I have to do a 5-number summary first, right? Because that's what the box plot is. It's a drawing of the 5-number summary. So the 5-number summary, I'm just going to write it out here. And then we can draw our plot. There it is. That's my 5-number summary. My min, quartile 1, quartile 2, quartile 3, my max. So I guess I'll just jump down. I guess I'll do it right here to draw it. Okay. So my scale, let's see. My lowest value is 4, go up to a little over 10. So I want to run out of room. I am a little bit sorry about that. Okay, so my minimum value. So remember when we start, we put these middle 3 values. So it doesn't have to be perfect, guys. 727, 764, and then 5 right here. Here is my box. Okay, it looks like my median a little bit closer to quartile 1 than it is from to quartile 3. So before I go any further in my box plot, I'm going to continue actually with these problems like with part B, because I don't know if my whisker goes to the 4.5 or if there's an outlier over here. And the same thing with the 10. I'm guessing 10 is not an outlier because it's kind of close to my box, but 4.5 could be. It's kind of far. So I'm just guessing. I don't know. So I'm going to go ahead and start looking at the next problem. So it says in part B, in the box plot, any rates below or above. So this is calculating my outliers, my fence in part B, my cutoff values. So remember for the lower fence, this is quartile 1 minus 1.5 times the IQR. Okay, IQR is quartile 3 minus quartile 1. So when I plug these values in, I get a lower fence of 5.3575. So my fence here, like right here, my lower fence. So any number outside of this, below this, is an outlier. Look at that. That 4.5 definitely is an outlier. All right, my upper fence, quartile 3 plus 1.5 times IQR. So for this, I get 10.4575. Okay, so this one's up here. So I'm kind of squishing it in. I apologize, my scale's not great, but my max is 10.1. So that's definitely within. So any number above that 10.45 would be an outlier, but my max is 10.1. It's inside my fence. So on my upper side, I'm just going to go ahead and start with that. The 10.1, that's where my whisker is going to go to. So my whisker goes to, this is the biggest mistake people make, or the most common mistake, I should say. It's not really that big, but it's the most common. They don't draw their whisker properly. So you have to draw your whisker to the largest value inside your upper fence, right? So you want to go all the way to the value that's closest to your upper fence, but it has to be inside the fence. It doesn't go outside, which we don't have to worry about it. There's no outliers outside on that side. Now on this side, I have to go through and look at my numbers. Thank goodness these are organized in numerical order. So I can see it's 4.5 and it goes to 5.7. Well, my lower fence is 5.3. So what I'm saying here is I know that that 4.59 right here is an outlier. I'm going to mark that. Now my fence goes to the smallest number, but that's inside the fence, closer to my box, but the smallest one. Well, the smallest one's the next one here is 5.77. So 5.77, somewhere around here, is where my whisker goes to on that side. Okay. All right. So we're getting there. Now I want to, well, part C says add the value. So we're already doing that, right? And it says add the mean. So the mean, again, I could just get right from my calculator from that one variable stats. So the mean would just be my X bar. And my mean here is 7.823. So what I want to do is I want to mark that with a plus sign with a circle. So 7.8, so this is 7.6, so it's a little bit above this. Right there it is. Put it right inside my box, okay? Now it says use your box plot to answer each of the questions below. All right, so what is the typical value? When we're looking at a typical value, that's the center. When we're looking at that in a box plot, it's the median, okay? So my center here is equal to the median, which is equal to quartile 2, which is 7.64. What is the spread? Now the spread when we're looking at a box plot is always the IQR. It's the width of my box. It's quartile 3 minus quartile 1. So here I get 1.2, and I don't, my paper's cut off. I don't know if it's, we'll just leave it. So here I have, let's see here. For number 3, what is the shape of the distribution? Now this one's tricky, I think, for this problem. So I have this outlier and it looks like a longer whisker over here on the left, but my mean is greater than my median. And I always use that over even what this looks like. So this can be tricky. If someone said this is symmetric, I would accept it. So it's kind of a tricky one. But when I look at my mean is greater than my median, right? It's larger than my median. It means it's to the right. It makes me think that it's skewed right. It's a little tricky, okay? But if you said symmetric, I would agree with that as well. I think it's a tricky one. Are there any outliers? Yes, there are outliers, 4.59. Now I think on your papers, I don't have it on mine, but I think I saw it yesterday in class where someone asked me, I think there was a 5th one, like what does an outlier, what would an outlier affect? What values? So an outlier can affect the mean, right? We'll pull the mean. Standard deviation. Those are the 2 main things. It's not going to change the IQR. It's not going to change quartile 1, 2, or 3. So the mean and standard deviation, I believe, is what I would put for that. All right, so that was number 6. Let's see, one more, which is number 9. Another hypothesis test. So number 9, I'll try to move quickly through this one, not take too long. So we're studying elementary school kids and how much time they spend playing video games. So the objects in here are the children or elementary school children or young children. You can write it so many different ways. So you can be specific. I always think being a little bit more specific is better because then you have more detail. your variable is time spent playing video games. My unknown, since it's time, that is numerical. Let me write that down. We use that, right? Going forward. So my unknown is mu. Mu is always the population mean, right? But now I'm going to add some context to it. So I have to read a little bit more because I just kind of skimmed it real quick. So let's see. So we have a third sample of 31 children, found their average time spent playing video games is 2.5 hours, deviation of 0.5. So we want to know, is the mean time more than 2 hours? Okay, so mu is the population mean time spent playing video games by elementary school children. How about that? Something like that. Or it's the population mean time all elementary school children play video games. I don't know. You can write it all different ways. So mu is the population mean time spent playing video games by elementary school children. Something like that. And then I have my goal. You know, I'm going to leave that for a second and I'll come back to it. My method here, my null, alternative, alpha, and my curve. My curve is the t-curve because it's numerical. And I always want to include degrees of freedom equals n-1. Alpha in this problem was given to me 5%. So again, 0.05. Now my HA is what they're trying to prove, and it says more than 2 hours. So my HA is mu is greater than 2. So my null is mu is equal to 2, or I could just write it mu is less than or equal to 2, like that. All right, so I'm going to go back up to my goal. So now I know mu is greater than 2. So I'm just going to take this whole statement I just wrote up here and then just tack on greater than 2 hours. So to say that the population mean time spent playing video games by elementary school children is more than 2 hours. There it is. That's my goal. All right, let's take a look at that sample. So for my sample, I'm going to take the information from this statement. So this is a sample of 31. And we found an average of 2.5 and standard deviation of 0.5. So here for my sample, since it's numerical, I need some little bit different information than I did for categorical. So I'm looking for X bar and S, N, and checking for normality. X bar is 2.5, S is 0.5, N is 31. My normality check I'm going to use N is greater than or equal to 30 if I can, and it is, it's yes, it's normal because of that. Now remember, if this does not come out to be true, it's not that it's not normal, it just means I can't use that to say it's normal. If that's the case, I'm going to plug my raw data, which I don't have in this one, but hopefully I would have it, into my calculator, get my NPP, then with my NPP, see if it's linear. And if that's the case, you don't need to show me your drawing of the NPP, but you could just say NPP is linear. Yes, normal, that kind of thing. Okay, so that's if N is not greater than or equal to 30. I always use this if I can. It's like the easy way out. All right. My results here. So I'm looking for a t-test statistic. Since it's numerical, I need to describe what that means, to interpret it. I need to find my p-value. and interpret that value. So again, I'm going to grab my calculator. If you do these by hand, it's fine. Just know that you can look up the notes from chapter 10 and see those calculations, right? You can watch the video on those calculations if that's what you want to do. It just means I'm going to use the test function in my calculator instead of using the TCDF function here, and instead of doing this by hand. All right, so I'm going to go to stat, arrow over to test. Now this one is option number 2, t-test. So t-test, I have stats. Stats means I have X bar and S. Mu naught is the center, that is 2. X bar is 2.5. It's my sample mean. S is 0.5, my sample standard deviation, N is 31. Now remember this next line right here, I want it to match my HA. I want it to be greater than. It's already on greater than, so I'll just go down to calculate. Now here, for my test statistic, I'm getting my value to be 5.5678. Now, like always, I try to use more decimal places here and round more at the end. The reason why I would leave this longer here, because if I did the p-value by hand using the TCDF, I would want to use as many decimal places as I can so I can get a more accurate answer for my percentage or my probability in my p-value. Okay, so I try not to round too much in the middle of a problem if possible. All right, so what this stands for, I'm going to say that my X bar is 5.5678 standard errors above, because it's positive, my center of 2. Now my p-value, I'm going to go back to my calculator. My p-value is the second, it's really the third line, but it's like the second value given to me. Sorry, you guys cannot see that. It says 2.3. When you see a number for your p-value that is above 1, I hope you recognize it's wrong. And it's wrong, meaning that I'm not reading the number correctly. Look, it's 2.3 and all the way over here, e to the -6. So what my p-value is, 2.3, I'm going to round properly, 5 times 10 to the -6. What that means is that I have to move my decimal place 6 places to the left. So that means I have 5 zeros in front of my 2. That's the number. So if you see a number that's not between 0 and 1 right here, okay, remember it's a probability. It has to be between 0 and 1. If it's not, make sure you look all the way over to the right. Okay, you probably did your calculation right. It's probably you're just not reading it right here. I hope you recognize that. Okay, you remember that. If you see something like this, I'm just going to go ahead and say this is very small. I'm not going to keep writing that number out. Anything smaller than like 0.001, I write very small. Okay. I am going to draw a quick picture. I like to see what I'm looking at here. So now remember we're on the T curve. The center is 0, and we're looking at 5.5. That is really far, right? Over here. That is really far from the center. So I'm just going to say if the population mean, because that's what we're looking at, is 2, there is a very small probability of getting a sample mean. So another X bar, at least as extreme as the one we got from sampling. So it's just saying that here's my 5% cutoff in the blue, okay? So I'm just saying that a very small chance of getting another sample this far away from the center or even further away. That's what the at least as extreme as means. Okay, so there's all my calculations for my test. So now let's put it together. So I'm going to take a look at my conclusion step. Is very small, less than or equal to 5% or 0.05. Yes, we can reject the null. So what I'm saying here, when I write that statement, I'm saying I do not think my population mean is 2. I don't think the null is true. That's what I'm saying right there in that statement. So I don't think it's 2. What I'm going to say is that I think I support that it's greater than 2, and that's my HA. So at the 5% level of significance, we can, so can, yes, right? All positives. Say, and I'm just going to rewrite my goal, that the population mean time spent playing video games by elementary school children is more than 2 hours. So we are saying that. We think the center of our curve should be moved to the right. We think it should be greater than the 2. That's what we're saying here in our statement. All right, guys. So I hope this review was very helpful. Keep in mind that the other 4 problems are in a different link on a different video. Okay, and I did tape those from a review session. So I don't know if there's any other information given in there about the final, but remember, don't listen to that if that's the case. It's everything for the final will be posted on SIS. Thanks a lot, guys.